Hello, what's up, guys? I do hope that you're doing great. In today's video, we'll be looking into one of the topic that has, that is quite important. So, we'll be looking into the water and its properties, like water, H2 and its properties, uh, how it reacts, how is it behavior, and all that stuff. So, first of all, let's get into the introduction of water. Okay, so let me tell you how much water is existing in our nature. So let me zoom a bit, and like we have got, let me tell you that we have got, for suppose this is, if earth is divided into three equal parts. This is a statement which is given in the book, and we need to understand that what this means. Like if we divide earth in three equal form, like we do maybe like this, and we do like this. So suppose that this is first, this is second, and this is third, and this is earth, and these are all equal. This is equal to this is equal to this. Then what do we mean to say is that we have got three parts. So among of these three parts, two parts are occupied by the water on the surface of earth, right? So here you can see like this is water. Let me do it. Okay, so let me do it. So two parts among the three, like this this is water over here. Like we have seen, this is water here. Here you can see that this part, the one is covered with water, the second is covered with water all around. Just I'm giving you a concept. If the water is going out of the surface, but look, don't look into that. We've just got a concept that if we got three parts, among them two are just covered with water, and this shows the significance of water. And moving forward, even though it is also present in humans or the living organisms with amount of around 70. Okay, living organisms have water equal to 70 to 90%. That is quite a huge amount, right? They've got 70 to 90% in their cells, the percentage of water. And of course there is something special in water. And if we look forward, it is said to be most abundant compound. Sorry, that is not most abundant, that is, yes, we can see that it is covering around 70% of the earth. And if you see that, like we are giving an average that it is around 70 to 90%. We have also got cells, like we have got seeds, and we can say that the bone cells, they are quite dry, right? So they have got 20% of water. Even though no cell can exist without water, the one which are dry even contain 20% minimum water. And the most, the most special cells, the brain cells have around 90% of water. I do hope that you are understanding like what is the significance of water. The the brain cells make us run, uh, so they are being occupied 90% by water. There is something special. There is a transparent fish like jellyfish. So that is around 99% of water. That quite be shocking, but that is truth. Like we have got a transparent type fish, and that is surviving on the water, and that is 99% of water. Oh yes, moving forward, uh, we have got chemical reaction in cell occur in water. Presence takes part in many biochemical reactions, and we've also got, it is also helping in photosynthesis. Like we have got some of the uses like it has uh, the cell cell reactions, like metabolism takes place. We can say that metabolism metabolism. We are also surviving on it, right? Survival. We feel thirsty. uh, Photosynthesis. So these are kind of very basic and important uh, processes of life, and water do play a important role in them. Now we'll be looking into the properties of water. Like water, we have got H2O. So what is something special in this H2O? Why don't H2O2? Why we cannot have H2O2 for the survival? Why only H2O? And what are the properties that make it something special? Like this, right? So this compound is quite different, and let me show you that this is said to be a polar compound. What do I mean by said that? Right? Polar compound, dipole, dipolar, right? So this means that here is kind of positive and here is kind of negative. What is the reason behind that? Like oxygen has taken two atoms or two electrons from hydrogen, and here it has gained negative charge, and hydrogen has gained his two electron to the oxygen has got a positive charge. I do hope that you have you know about the chemistry, right? So this is the reason. And if we look into the other phase of it, like uh, you can see that why the positive and negative, why isn't it neutral? Because there is kind of a difference in the sharing of electrons. We have got two electrons from this side and one from this side, so this is a difference, and this that makes it dipole. So because of that, the electronegativity difference, we have got positive and negative both, and water is special. And moving forward, we have got that uh, okay, wait a minute. Okay, so back to the topic, right? We'll be looking into properties of water. So properties of water. So the very first property of water is something kind of special, that is hydrogen bond. Hydrogen bonds. And here comes the adhesive and cohesive force, right? So let me tell you a thing, that this is H2O, like this is oxygen, and yes, this is oxygen, and this is hydrogen. Like this is water, kindly simply H2O. Okay, so what happens is that uh, let us consider two to three more atoms in this. So here is another atom, and like this, and we have got mm, like this, and then this. Okay, so let me draw the hydrogen. This is hydrogen 1, this is hydrogen 2, this is hydrogen 1, this is hydrogen 2. So these are the molecules of water, right? H2O, a single molecules of water. Three molecules are present over here, and we have seen that this is a dipolar compound. Like this is having positive, and this is positive. These are having positive charges, right? This is negative, 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 negative. So what happens is that uh, basically these charges make water molecules attract to one another, right? So due to this, what happens is that these attraction bond are formed between them. Like I'm making dotted lines for this because this is a rule that you make hydrogen bonds with dotted lines, because these are temporary bonds. These are temporary bonds, like positive oxygen and other molecule negative hydrogen, and this makes them flow. Like we have seen water, it does not, it flows, in form of group, right? Water flows all together. So this is the reason we have got this bonding. This bonding is called hydrogen bonding. This is hydrogen bonding, and this is kind of covalent bonding. This is kind of covalent. This is permanent covalent covalent bonding. This is kind of permanent, and this is kind of temporary, because these are not actual bonds. These are temporary weak bonds that are made, and this is because of the dipolar property of water, and this helps us to know that water flows in one way, right? It gets all together. If you drop the water from a glass, so it will not drop like one by one drop will be dropping. It will be dropping in a sequence, in all together, right? There is a link between the molecules. This is the reason, and due to this, of course, there is some kind of force being created. These are the hydrogen bonds, right? And the force of attraction, due to this, there is a force applying over here. Let me mention it with some other color. Like we have got a force over here, there is a force over here. Okay, so wait, so here is a force applying between this, and that is actually the cohesive force, the attraction force, cohesive force. So let me tell you a thing, that uh, the attraction, and tell you the definition. uh, Cohesive force, attraction between water molecules due to the hydrogen bonds, H bonds. Don't confuse it like this. What is the difference between hydrogen bond and cohesive force? Because they both are making water molecules stick together, right? But hydrogen bond is a kind of temporary bond, while cohesive force is a kind of force that is present due to the hydrogen bonds, that is a result of hydrogen bonds. And due to the hydrogen bonds, uh, you can also say that we have got polar nature right here. So let me consider that we have got, like this, we have got NaCl, Na positive. Okay, wait, Na positive, Cl negative, right? This is another compound that is present, and what happens is that uh, there is a force of attraction between this. Okay, wait, there is a force of attraction between this, because this is positive, negative, and whatever we do, what sort of compound we do take that is having a polar nature, so there is a kind of a uh, you know that is a kind of a attractive force in the other molecules. The We can say that, let me write the definition first. So cohesive, adhesive force, that is quite very similar to the cohesive attraction between water and other polar molecule due to hydrogen bonds. So this is kind of a thing, like if you've got other compound with positive negative attracts, that is quite a chemistry thing. So these are the very first property of water, and we looked upon its importance, and the very first property of the hydrogen bond, that is the most important property of water, the hydrogen bond that makes it flow, even though it helps in many things like uh, this helps is the flow of blood, the chemical reactions do take place, and the stability of water, the linking of water. Like we have got what if we drop the water from glass, so it drops like in the form of molecules. So this is not happening because of the weak hydrogen bonds. So that is quite a great thing. So meet you guys in the next video. In the next video we're looking into the remaining properties of water. Like we've got many remaining properties, like specific heat of capacity, specific rate of vaporization, and many. So meet you guys in the next video. Till that, goodbye.